So welcome back to Master Academy of Mathematics. This is the last topic in your higher order ordinary differential equations. So this method is method of variation of parameters. So in order to apply this particular method for higher order ordinary differential equation, remember that should be only in the second order. That means d square y by dx square plus p into dy by dx plus qy equal to r. Only in that particular form you can apply your variation of parameters. So I just give you the procedure. The first step is given differential equation that should be compulsory in the form of d square y by dx square plus p dy by dx plus qy equal to r. Here p, q and r, these are the functions of x. Now find out the complementary function by finding the auxiliary equation f of m equal to 0. And you are supposing yc, that is the complementary function, it is equal to c1 into u plus c2 into v, where u and v are nothing but functions of x variable. Then you are finding the particular integral yp equal to au plus bv, where a can be calculated as minus integral of Vr divided by udv minus vdu of dx, and b equal to integral of ur divided by udv minus vdu of dx. So just you calculate a and b values and substitute in your yp, that gives you particular integral. Now find out the complete solution y equal to yc plus yp. So this is the brief procedure of method of variation of parameters. So here is a problem. Solve d square y by dx square plus y equal to cosec x by the method of variation of parameters. In the examination point of view, definitely they are going to mention the method. If method is not mentioned, you can use your previous methods. Okay. So I am applying method of variation of parameters for that particular problem. Before applying that, it should be compared with your standard form of variation of parameters. What is the standard form? D square y by dx square plus p into dy by dx plus qy equal to r. So just you write down what are the different values of p. What is p? P into dy by dx. There is no actually dy by dx. That value is 0. And what about the q? Q into y. So y coefficient is 1. And what is capital R? Which is right side value, that is nothing but cosec x. So the given differential equation, exactly it is looking like the form of method of variation of parameters. Now you can apply your method of variation of parameters. So in order to find out that, first you are writing in the symbolic form. The same thing you can write d square plus 1 of y equal to cosec x. So this is exactly looking like f of d of y is equal to some right hand side, I am just writing as it is cosec x. Now you find out auxiliary equation. What is the auxiliary equation? F of m equal to 0. That indicates m square plus 1 equal to 0. So what are the values of m? It is plus or minus I. So roots are real or complex? Complex. So when the roots are complex, I can write yc equal to, it is c1 into cos into imaginary part x plus c2 into sine of imaginary part 1 into x totally multiplied by e to the power of, there is no real part, so 0 into x. Or I can write c1 cos x plus c2 sin x. This is about your yc. Now as per your procedure of variation of parameters, yc that should be taken as c1 into u plus c2 into v. So compare with your calculated yc. What is the u? U is nothing but cos x. And what about the v value? It is nothing but sin x. Now after getting this yc, now you are calculating yp. So what is the procedure for yp? Just you are finding au plus bv. So a, we need to calculate a, and u value is nothing but cos x, plus b you need to calculate, and v value is sin x. So now we need to calculate A and B values so that you will get yp value. Now before calculating A and B values, first you calculate udv minus vdu. So what about the u? U is nothing but it is cos x. dv means derivative of v. V is nothing but it is sin x. Sin x derivative, again it is cos x. Minus v as it is, that v is nothing but sin x. Du, that means derivative of u. U means cos x derivative, minus sin x. So just I am making the simplification, cos square x plus sin square x, that becomes the value is 1. Now after getting this udv minus vdu, just I am finding A formula is integral minus integral of v into r divided by udv minus vdu. So this is of dx. It is equal to minus integral of, what about the v value? It is sin x. What is r? As per the problem it is cosec x divided by udv minus vdu value 1. This is of dx. So now this is equal to minus integral of, what about cosec x formula? It is nothing but 1 divided by, shall I write sin x? Yes, divided by 1 is as it is and it is of dx. So minus sin x is cancelled, integral of 1, that becomes x. So finally you are getting the answer is minus x. That is your A value. Now you are finding the B. The formula is integral of ur divided by udv minus vdu. It is of dx. This is integral of u. What about u? It is nothing but cos x. And what is r? It is cosec x divided by udv minus vdu is 1. It is of dx. This is equal to integral of cos x. Cosec x can be taken as 1 divided by sin x. Cos by sin, which is nothing but cot x. It is of dx. What is integral of cot? It is logarithm of sin x. So this is about B. So therefore directly you are calculating yp. It is AU. A means it is minus x into u is cos x and plus BV. It is logarithm of sin x into v is nothing but sin x. So this is about particular integral. So therefore the complete solution is yc plus yp. Just you substitute the values, you will get the complete solution of your given differential equation. Now let us have certain exercise problems on method of variation of parameters. The first one, d square plus 1 of y equal to cos x. You apply the same procedure, you will get your final answer. Similarly, d square plus a square of y equal to tan ax, and d square plus 4 of y equal to sec 2x, d square plus 1 of y equal to cosec x cot x, d square minus 6d plus 9 of y equal to x power minus 2 into e power 3x. So only the thing is you need to have little bit of patience in order to get your A and B values. Once you make the simplification, you can find out directly particular integral and its final answer. So with this, your method of variation of parameters is closed. So I am going to close your complete higher order ordinary differential equation with this method. So with this, your complete second unit is closed, higher order ordinary differential equations. So if you want any important and information regarding to first two units, better you comment in the WhatsApp group, and if any doubt clarification is there, better you make a suggestion or any doubts I will be clarifying in your WhatsApp group. So that will be given in the description part, and in the next video session we directly enter into one more important unit, which is multiple integrals. Have a good day.